All right, so question 15.11, the second half of chapter 15 homework for Brianna and Naja. The following diagram represents the equilibrium mixtures for the reaction A2 plus B goes to A plus AB at 300K and 500K. So the reaction A is 300K and the reaction B is 500K, and it basically asks us, looking at these two equilibrium mixtures, can we determine if the reaction is exothermic or endothermic? So what we have to do is figure out where is the equilibrium for both of these, and then how does the equilibrium change between 300K and 500K to determine if it's an exothermic or endothermic reaction. So how do we get that equilibrium? Just using the definitions. So A is red, so this would be A, this would be B, this would be AB, and this would be A2, would be double red. Now, what's our equilibrium levels for both of these? So we're going to have A2 plus B goes to A plus AB. And our reaction at 300K, we can look and see we have one molecule of A2 and we have one molecule of B, and that equilibrated to 1, 2, 3 molecules of A, 1, 2, 3, 4, 5 molecules of AB. Now our reaction at 500K, we can look and see we've got 1, 2, 3 molecules of A2, 1, 2, 3 molecules of B, and that equilibrated to 1, 2, 3 molecules of AB and 1 molecule of A. And so if we look at these two reactions, and where does the equilibrium lie for both of these? So at 300K, we have a higher concentration of products, 3 moles of A, 5 moles of AB. At 500K, however, we have a higher concentration of reactants, 3 moles of A2, 3 moles of B. So clearly, as we increase the temperature, the equilibrium of the reaction was pushed to the left. We somehow, at a higher temperature, favored the formation of the reactants, favored the equilibrium mixture on the side of the reactants. So knowing what we know about Le Chatelier's principle, how basically we make a change and the reaction shifts in a direction to help adapt to that change, to help use that change. So what did we do? We added heat to the reaction, and the reaction shifted left to help use that heat. So based on that, this must be an exothermic reaction because, right, we added extra heat to the mixture when we went from 300K to 500K. So because it's an exothermic reaction, if we increase the amount of heat, right, the reaction is going to shift in a way, the equilibrium is going to shift in a way that uses heat as a reactant now. So to use heat as a reactant, the reaction has to shift to the left to favor the formation of the reactants. And so as a result, right, this was an exothermic reaction at equilibrium, and we saw that because when we increased the temperature from 300K to 500K, the reaction shifted to the left, and it moved left to help use some of the heat given off by that reaction. So it's an exothermic reaction.